Welcome to Solving Problems with Parts. So up until now, for all calculations in which a single unit amount was wanted, we had one item in the data with a single unit amount, with the rest of the data then in ratios, which we wrote as equalities. But you're going to run into problems in which all of the data is in ratios. And to solve these types of calculations, then, you're going to need to choose which single unit amount to start with in your calculation. So let's look at an example. In 1988, Florence Griffith Joyner set a women's world record in the 200-meter dash with a time of 21.34 seconds, and we're also given that 1 mile is equal to 1.609 kilometers. And we can ask a few questions about this. What was the length of the race in miles? What was the time of the race in hours? And what was her average speed in miles per hour? And we're going to label these questions A, B, and C. So in problems with one set of data but multiple questions, it's often helpful to write the data section first and then write the wanted unit for each part. So I'm going to ignore C for the moment. We'll come back to that later. But we've got now our data, 200 meters is equal to 21.34 seconds because we know that she ran 200 meters in 21.34 seconds. We have 1 mile equals 1.609 kilometers because that's what we were given in parentheses. And then in part A, we want the number of miles that she ran in the race. And in part B, we want the number of hours that it took her to run the race. So we now need to pick which quantity in our data section to use as a given for each part of our problem. And because this is a simple example, you can probably pick which quantity to use in each part. But most other problems in chemistry won't use such familiar units, so let's develop some rules for picking the quantity to use as the given. So when all data are equalities, but a single unit amount is wanted, then label each quality in the data as a ratio or as two related single unit amounts and a ratio, so either R or 2A plus R. And then choose from the data one single unit amount from two amounts that are related. So you don't get to pick from those things that you have labeled R, you only get to pick from those things you have labeled 2A plus R. And then you use this value as the given and pick the value that most easily converts to the wanted unit, but you cannot pick a value from a ratio, something that you've labeled R, unless that ratio is two related amounts, so the 2A plus R. So let's label each of our lines in the data for our earlier example. We've got the 200 meters is equal to 21.34 seconds. Well, both of these amounts are measuring the same thing. They're both measuring the race that she ran. And so this is two amounts and a ratio. The next line, we have 1 mile is equal to 1.609 kilometers. And here we just have the ratio between miles and kilometers. These are not two different measurements of the same object. So here we have our labels again. And again, that top line is two related amounts because both values measure the same object. This is the race that Florence Griffith Joyner ran. But the second line there is only the ratio between miles and kilometers. So let's pick a given to start with for each part. So for A, because we want miles, let's start with the distance unit. The distance unit that we have, again, we can't use anything from here, but we can use meters or seconds. Well, the distance unit there is meters, so let's use 200 meters. And for part B, we want hours, so let's use a time unit, 21.34 seconds. And now we can go ahead and solve. We have 200 meters. We can convert from meters to kilometers, kilometers to miles, and now we have 0.12430 miles. And note here that I've kept an extra digit past our last significant digit. Our last significant digit is written there with an underline. Down here in part B, we've got 21.34 seconds. We're converting from seconds to minutes, then minutes to hours, and so now we have 0.0059277 hours. And again, we've kept one extra digit. So again, note that I've kept an extra digit in each of these answers beyond that last significant digit. That last significant digit is the digit that I have underlined. And when we solve problems with multiple steps or multiple parts, it's often useful to keep an extra digit until you reach your final answer. And this will reduce rounding errors from rounding in each of your earlier parts, because if you're using the answer for one part to do the next one, and you've already rounded, now you're changing slightly your starting numbers that you're using in that second part. You still need to remember to go back and round your answers to the correct number of sig figs before you actually finish the problem, though. So it can also be helpful to circle or box the answers for each part, as those answers can also be used as data for later parts. So we can now solve part C of our example. We want a ratio unit, and so we need to start with a ratio. We want a ratio between miles and hours, but neither of these are in our data. But both miles and hours are in our answers to our previous parts. And thus we can divide miles by hours. So we have our miles here from part A, we've got hours there from part B, so we take miles divided by hours, and that gives us 20.97 miles per hour. So note that I've rounded the answer there to 4 sig figs because we have 4 sig figs in each of our numbers used in the calculation. When you need to solve for a ratio unit, there are 3 methods you can use. If you want a ratio, start with the ratio. The second method is solve in 2 parts. So solve for the top, solve for the bottom, and then divide the top by the bottom. The third method is to use a mathematical equation. So sometimes, in other words, for complex problems, it is necessary to solve using an equation. We can't do it simply with conversions alone. But most problems in first-year chemistry courses can be solved using the conversions, the dimensional analysis that we've been using up until this point. So you're free to use whichever method you prefer, but that first method, starting with a ratio, is usually going to be fastest. And if you need to use a mathematical equation, then you're going to need to solve in 2 parts, and then divide one by the other. So your best approach is to try method 1 first, which is starting with a ratio. And if you get stuck, then and only then try method 2, which is solving in 2 parts. And then if you get stuck again, then try method 3, which is finding an equation that solves the problem. So note here that this means that trying to find an equation to solve the problem should be your last resort. You should have no other idea how to solve the problem before you go trying to find an equation that will solve it for you. So make the flashcards listed on page 243 of the textbook, and then run these flashcards until they're all in your Got It stack. So that was solving problems with parts.